Hello guys, I want you to teach another way of getting this coefficient using what we call binomial expansion. Hello guys, I want you to teach another way of getting this coefficient using what we call binomial expansion. You realize that here we have 1, we have 6, we have 15, we have 20. We have 15, we have 6, and we have 1. Now, this can be gotten using what we call combinations using your scientific calculator. So, for instance, if I want to get this value, 6, I look at this value here, this is 6. I can count 1, 2. And I want to get this value. So if I want to get that value, it's my second. This is, I can write here and say 1, 2, 3, 4, 5, 6, 7. So if I want to get the second term, I will actually use this, say 6, which is this number. Then I talk about combination. It is my second term, I take 2 minus 1. This is actually 6 combination 1, which gives you 6. Maybe I can say, to get the first term, here we have second, we have third. When you are given a plus b power 6, first term will be given by 6 combination 1 minus 1, which is actually 1. Or, in other words, 6 combination 0, which is actually 1. The third term, which is this one, will be given by 6 combination 3 minus 1, which is actually 6 combination 2 equals 15. You can do that using your calculator. If you have a scientific calculator, you put 6, then you look at where the calculator is written NCR. You click shift, then NCR, then you put the 2. The answer it will give me is actually 15. The same, when I do 6 combination 3, the answer is actually 20. So I can get all this. 4, we have 6 combination 4 minus 1. This is 6 combination 3. This is actually 20. The fifth term is actually 6 combination 4 minus 6 combination 5 minus 1, which is actually 6 combination 4, which is actually equals to 15. Then we have the sixth term, which is 6 combination 6 minus 1. This is actually 6 combination 5, and this is actually 6. The last one, seventh term, is 6 combination 6. 6 combination 7 minus 1, which is actually 6 combination 6, and this is usually 1. Now, this is how you can get this using combination. Combination in the calculator appears like a C that has a line like this. It appears like a C that appears like a C and with a line that's what we call the combination. Sometimes you click shift and you look at where we have NCR. That's how you get combination. So we can say, solve this, a plus b power 6. So I will count 6 times and I have, we have a, ab, then plus ab, plus ab, plus ab, plus ab, plus AB. So let's see. You start with a 6. This one, you start with a 6 there, then a 1, a 0. Then you go to a 6, 1. You go to a 5 and 1. You go to 4, 2. You go to 3, 3. Then you go to 2, 4. You go to 1, 5. Last and not least, you will have 0, 6. I want you to observe a trend that A is power 6, B is power 0. The powers of B continue to increase. The powers of B continue to increase. So now I can put my coefficients. Yeah, my coefficient here is 1. The other coefficient here is 6. 1, 6, 15. Here we have 15. Here we have 20. Here we have 15. We have 6 and we have 1. Just when you look at this pattern, you realize that every time, for every term, the coefficients add to the 6. This 6 is actually what we call n. Then I can count 1, 2, 3, 4, 5, 6, 7. I can say this is my R term. R term. The numbers here, this is my actually third term. Third term, which is actually what we call R. So this means we can actually get this R term. We may want to get the R term. Anytime we want to get the R term, it is clear that to get the R term, I will take 6, which is actually my n, combination. If it is the third term, here, I will actually use 3 minus 1 to get this 15, 6 combination 2. So here I will say R minus 1 because it's my third term. Then, now I can say, whatever I get here, I will have a B, R minus 1. Then I get N, which is actually 6, minus R minus 1. This changes to positive. So that means I can now relate this to N, C, R minus 1, A, N minus R plus 1, B, R minus 1. No matter the term you want to find, this is the formula that you shall use. This is the formula you shall be able to use. And you're able to get a complete term like this. If I know my R is 4, for instance, the fourth term, I can get the fourth term. That means my R equals to 4. That means my R equals to 4. If I'm using this formula, I will use 6 in this equation because 6 is my n. 6 combination 4 minus 1. Then I have A, 4, n is 6, 6 minus 4 plus 1. Then you have B, 4 minus 1. I'm looking for my fourth term, the fourth term. So that means here I'll get 6 combination 3. I'll get A, 6 minus this is 2, plus this is 3. Then I get B, 4 minus 1 is actually 3. If you compare this, 6 combination 3 is actually 20. You can do that using your calculator. 6 combination 3 is 20. So we have 20, A power 3, B power 3. You look at this, it's exactly what we got here. So this is the formula that we use when we are doing binomial expansion. Instead of using that formula, you can use this. Alternatively, you can use what we call factorial. Factorial formula, you can actually say n factorial. This R minus 1, I say factorial. Then I pick this n minus R plus 1 factorial. Then I have A, B. This is the power for B, R minus 1. This is the power for A, n minus R plus 1. Get this. Thank you.